Okay, so today we're going to talk about weighted averages. And so I have a handout that is pretty much everything that is on the screen except for this first slide. So that way you don't have to write the problems down. You can just go through and work out the problems as we go through them. So if we were to take a quiz or do anything of that where you would need notes, this does count as notes. So, first of all, weighted average is what we do in class to find your average, believe it or not.
Oh, yes.
Okay, because we use weights. And basically, you find the weighted average by multiplying each data value by its weight and then finding the mean of the new data set. And then we have mixture problems where two or more parts are combined into a whole. So if you look at the very first problem, oops, skipped it. It said Tasha ordered soup and salad for lunch. If she ordered 10 ounces of soup for lunch and the total cost was $3.30, how many ounces of salad did Tasha order? So first of all, if you notice, soup is 15 cents an ounce, right? How much soup did she order?
10 ounces.
10 ounces. So I'm going to put down here the amount that she ordered. So she ordered 10 ounces. She ordered 10 ounces. There we go. Finally got that in. And then 20 cents an ounce. How much of the salad did she order?
We don't know.
We don't know. So what could we call that?
S.
X, S, something to that effect?
S for salad.
Okay, I would normally put S. The problem is sometimes when people use S, it resembles a 5. So I've seen Miss Stacy made that way. And so now what I'm going to do is I'm going to multiply those. Okay, so I'm going to multiply 15 cents an ounce is 0.15 times 10. I'm going to add that to 0.20 times X, and that will equal what? $3.30. So now, it's just a process of solving this equation. The hardest part of today's assignment is going to be writing the equations. So let's go ahead and distribute. What is 0.15 times 10?
1.5.
1.5, $1.50. So then to solve that, what do I need to do next?
Subtract 1.5.
Subtract 1.5. And on the left side, I am left with 0.20x equals what? Equals $1.80. What do you do now?
Divided by 20.
Divided by 0.2 or 0.20, and you get x to equal
0.9. I got 9.
9. So how many ounces of salad? 9 ounces of salad. Okay. Questions on that? That's an example of a mixture problem. Now if you look at the next mixture problem, that's what we're going to look at again. Okay, except for it's not going to be as nice and neat with the salad and the soup. One type of antifreeze is 40% glycol. Glycol, does anybody know what that is?
Something that does that melts ice.
Okay, glycol is like an alcohol solution. And another type of antifreeze is 60% glycol. How much of each kind should be used to make 100 gallons of antifreeze that is 48% glycol? So what ends up happening is we have 40%. So this is just like the soup and salad except for we don't have the nice little pictures to go with. We have the 60%. And I know together that's going to equal 48%. So let's plug in what we know. Okay, we know how much of the 40% is used. We don't know. We're going to call that X. Okay. We know together how many gallons do we have if we add both the 40% and the 60%?
100.
100, right? So 60 here is going to be 100 minus X. Now, for those of you that are a little confused, let's think about that. If I had 10 gallons here of 40%, how many would I have to have of the 60? 90. If I had 40 gallons of the 40%, how many gallons would I need here? 60. Okay, and so how we find this, we take whatever amount is total, 100 minus X. And then we're going to have 100 total gallons of our final solution. So what are we going to do with those numbers? What? Yeah, write an equation. What are we going to do with the 40% and the X? multiply them. So I'm going to take 40% times x. I'm going to add that to 60% times 100 minus x. And that's going to equal 40%, or 48% times 100. Don't worry, we're going to have another one if things aren't quite clear. We've got another example like this. So I have 0.40x plus, what do you do with the 0.6 here? Distribute. So what is 0.60 times 100?
60.
60 minus 0.60x, and what's it going to equal? 48. What do you do now?
Subtract 40.
Let's add like terms first.
Oh, wait.
Okay, like terms first. So what do I get when I add those two together?
Point
Negative.
1x.
Negative 20, nice job.
Oh.
Plus 60, and that's going to equal 48. What do you do now?
Now you subtract.
Subtract 6.
Subtract 60. So see all that equation stuff that we were doing? Yeah, you can see why. So on the left side,
Then we can.
you are left with negative 0.20x equals
Negative 12.
negative 12. What do you do now?
Divide by negative 0.2.
Divide by negative 0.2. And so what does x equal?
60.
60. So let's go back and they say how much of each kind should be used. So x here is 60. 100 minus 60 is how much?
40.
40. So let's answer that. So we know that we have 60 gallons at what percent?
40.
40%. And we have 40 gallons of the
60.
60%. All right, so now let's look at the next one, because the next one deals along the same lines here. Margot has 40 milliliters of a 25% solution. How many milliliters of 60% solution should she add to obtain the required 30% solution? I want you to start writing an equation for that. Okay, start writing an equation. Write what you think you should start that problem with. Now, just a little heads up, it's not totally the same.
Dang it.
It's close. Very first, what's my first percent I'm dealing with?
25.
25%, good. So that's my first amount. So that's a place to start. What's my next percent going to be? 60. And then that's going to equal what percent? 30. So that's always a good place to start. Write down our 3% here. So now 25%. Do we know how much of the 25% we have?
40 milliliters.
40. Do we know how much of the 60%?
No.
No, so we call that
And
X. And then 30%, do we know how much that's going to be?
no.
Let's see, does anybody have a thought? Yeah.
40 plus N.
Ah, 40 plus X. For those of you wondering, okay, these two blue numbers have to add up to get this number over here. These two add up to get this number over here. File that away. So then now, I'm going to write my equation. My equation is 0.25 times 40 plus what? 0.6 times x. Or 0.60, I mean it's the same thing, equals 0.3 times 40 plus x. So what do we do now? Distribute and do like terms. What is 0.25 of 40? 10. So now if you distribute, what do you get here?
Oh, 12.
12
plus that.
plus 0.3x.
Yes.
Okay. So we've got variables on either side, so we need to get the x's on one side. What side do you want to get the x's on?
Left.
That's a good thing. So I'm going to go ahead and subtract 0.3x, folks. So on the left side, you are left with 10 plus 0.3x. And what will that equal? 12. What do you do now?
Subtract 10 from both
Subtract
sides.
10 from both sides. Good. So I get 0.3x equals what?
2.
2. How do you solve that?
Divide by 0.3.
Divide by 0.3. So what does x equal?
6.6 repeating.
6.6 repeating. So a good rule of thumb is to always go, you can go 2 decimal places.
6.67.
Yep, 6.67. Okay, we could do 6.6 repeating, but it's kind of good. So if I plug that in up here, I get 6.67. Let's see what it says. How many milliliters of 60% solution should she add?
Milliliters.
So 6.67 milliliters is abbreviated that way, a little m and a big L. Otherwise, you could write out milliliters.
Wouldn't it, but don't you have to figure it out? No, you just gotta.
All right, so let's look at the next slide. The next slide on your sheet is uniform motion problems. Biggest thing you need to understand from here. Distance equals rate times time. And you actually do this quite a bit, okay? Because imagine, you're going to go to, I don't know, Omaha. Omaha's about 120 miles away, maybe, if you would say that. Okay, and so if you average 60 miles an hour, how long is it going to take you?
2 hours.
2 hours. Okay. So let's look at the problem here. It took jogged 2.5 miles in 16 minutes, and then he walked 1 mile in 10 minutes. What was his average speed? So distance equals rate times time. What is Austin's distance?
Is distance
3.5
miles.
3.5. Oops. 3.5 equals R times what?
26 minutes.
26. So notice this is miles. This is minutes. What do you do now?
Divide by 26 minutes.
Divide by 26. So what does that come out to be?
0.13 miles a minute.
0.13 miles per minute. I'm having trouble with the pen there today.
Is there any way to abbreviate miles per minute? You just have to
Nope.
And then you have to find
Could
out
you
my
put miles
hour.
per MIN?
Yeah, you could do miles per MIN. We'll put-
And
Okay, but don't use M for miles because that's always abbreviated for meters. All right, questions? All right, let's go ahead and look at the next one. Okay, there's your next one. 2 trains are 550 miles apart, heading toward each other on parallel tracks. Train A is traveling east at 35 miles per hour. Train B is traveling west at 45 miles per hour. When will the trains pass each other? So basically what they're telling us is that we have 2 trains here. This total distance is 550. We have train A, which is going this way at 35 miles per hour. And we have train B heading this way at 45 miles per hour. when will the trains pass each other? So now this is the thing. We want to know when the trains together have passed a total distance of how far?
550.
550. Alright, so 550 is going to be what I start with. And that's going to equal. This train is going 35 miles per hour, right? Do we know how long he travels? Or it travels? Well, so we'll call it T, because that will be its time, right? What's the 45 mile an hour train's time going to be?
No, like N maybe?
This is the thing. They start at the same point, right?
Mhm.
So when they meet each other, they will have traveled the exact same amount of time. Now they won't travel the same distance. Who's going to travel further just for kicks?
45.
The 45, obviously, because he's going faster. So now we need to solve that. Yeah, what's your question?
Could you do 80 times T?
That's what we're going to do right now.
Okay.
So,
Wouldn't it be-
like
wouldn't it be-
terms, I get 35t and 45t, which is 80t. And then now to solve, what do you do?
Divide.
Divide by
80.
80. Good. So what does t come out to be?
6.88 hours.
6 point what?
8.
8. 8 hours. So the train is moving kind of slow. Alrighty, with that in mind. Okay, there's your assignment, page 136, number 6, 8 through 13. Now this is what I think we're probably going to do. It's looking like your test is going to be Thursday, Friday. Tomorrow I think we're probably going to have a worksheet over the last 2 sections. So the stuff we did Thursday, stuff we did today. And then we'll review, and then I think you'll have your test right towards the end of the week. Okay?